Hi, everybody. Welcome to my talk about end-to-end tests for plugins. I'm excited to share with you today how we can help make your plugins more reliable, save your time on manual testing, and give you confidence that new changes won't break your plugin's core functionality. Over the next 30 minutes or so, we will explore the testing framework we've developed internally and are now ready to share with you. But first, let me walk you through what we will cover today. First, I will show you how we test your plugins on our site and share our future plans there. Then we will look at new tools and the approaches you can use to write your own integration test. The main focus will be on our starter framework and its driver extension, testing tools that will help you get up and running quickly. Let me tell you a bit about myself and the team behind this work. I'm Maxim Kolmakov, and I've been with JetBrains for over 10 years. It all started when I was tasked with developing a performance testing framework for IntelliJ based IDEs. I found this work so fascinating that I'm still passionate about it today. Now I'm a tech lead in the IntelliJ Platform QA automation team. We are a team of 13 engineers responsible for providing integration test frameworks, test tools, and services across the entire IntelliJ department. We test core IntelliJ platform features like version control, indexing, code completion, AI assistance, and much more. We also help teams behind language-specific IDEs like WebStorm and RubyMine write their tests and integrate them into our common infrastructure. Recently, we started working with our large customers to help them implement performance testing on their side. Let me start by explaining how we test plugins on our side. Every time a plugin update is uploaded, it triggers an automated smoke test in TeamCity. While this test is basic, it's crucial. It catches major issues like startup problems, freezes, and platform exceptions. Here how it works. The test first gets the latest plugin update from Marketplace and the compatible dev version from our CDN. It then runs two tests. First, it starts the IDE without the plugin and records any exceptions. Then it installs the plugin, starts the IDE again, and tracks any new exception or freezes. Each time we wait for all background processes and indexing to finish before closing the IDE. By comparing these two runs, we can identify which issues are specifically caused by the plugin. There is one interesting case that often trips up the test. Modal dialogues on startup. These are particularly problematic because they block normal project opening and pause indexing, causing our test to timeout. And it's not just bad for testing. Think about a real user scenario. Your team has 10 required plugins, you open a project, and suddenly you have to click through 5 different model dialogues. That's why we strongly recommend using notifications or suggestions instead to get user attention. And here's something impressive. We run about 600 tests daily, checking roughly 100 plugin updates. The best part, most plugins pass. No crashes, no freezes, no exceptions. You are all doing great work. Keep it up. You might wonder how you will know if your plugin update passes this test. Currently, it's a manual process. When a test fails, we get an email alert, check the TeamCity results, and reach out to you through our marketplace support team. Yeah, it can be quite hands on at times, but don't worry, we will share our plans to improve this process later. When our support team contacts you, they will include a link to the test failure. We've set up a special TeamCity instance with guest access where you can see exactly what went wrong. You will find everything you need there: the error details, idea log, screenshots, and other files we collect during the test run. Now let's talk about how you can test your plugin before uploading to Marketplace. Good news, it's simpler than you might think. All you need is to add a few dependencies to your Gradle build, write a basic JUnit 5 test, and you are set. Your test can install the plugin that is built by IntelliJ Platform Gradle plugin, and run it on any operating system and any IDE version starting from 2024.2. Let me tell you about the tools you will need: starter and driver. They come as a Maven libraries, so adding them to your Gradle build is pretty straightforward. And here's a helpful tip: you can connect starter with IntelliJ Platform Gradle plugin by simply pointing it to your plugin's distribution location. Let me show you what a test looks like in practice. While you can write tests without interacting with UI, those are usually more complicated. So today we will focus on UI testing, which is more straightforward. Let's look at this example. It combines two key tools: the starter framework and its driver extension. Here, what is happening? Starter downloads the latest IntelliJ IDEA Ultimate, launches it without any project, and installs your plugin. Then, the driver part takes over and performs a series of UI checks. It waits for the welcome screen, navigates to the plugin settings, clicks the Install tab, and verifies that your plugin is actually there. Don't worry if the code looks a bit overwhelming right now. We'll break down each part in detail a bit later. The important thing is to understand the basic flow of what is happening. Let me show what makes the starter framework so powerful. It's the backbone of our testing setup. It gives you incredible flexibility in how you test your plugins. Think of it as your IDE configuration Swiss Army knife. You can use any IDE version, either download it or use your local installation. Set up test projects however you want, from remote zips, GitHub repositories, or your local projects. Fine tune everything: VM options, system settings, debug logs. Install plugins from the marketplace or your local build, configure SDKs, and much, much more. But here's what I really love about it. Starter handles all the tricky parts automatically. It manages IDE execution across different operating systems and collects all the important data like logs and screenshots. We use it for all our integration testing at JetBrains. And the best part, it is open source and ready for you to use. Let me share something interesting. Starter actually began as a performance testing framework and later evolved to include functional and UI testing. In fact, at JetBrains, it's still our go-to framework for IDE performance testing. And yes, you can use it to measure your plugin's performance too. It tracks commands execution metrics, captures CPU and memory snapshots, and can store metrics in any format you need. But here's the thing about performance testing: it is complex, really complex. Let me explain why. First, you need proper infrastructure, somewhere to store metrics, tools to visualize them, and ideally an alerting system. While tools like Grafana exist, they are built for web services and not IDE testing. We actually had to build our own in-house solution because nothing quite fit our needs. Second, you need the right testing environment. We've learned that only physical hardware or high-end AWS machines give you stable, reliable results. Virtual machines just introduce too much fluctuations. And here's the catch: these solutions are not cheap. Finally, there is the challenge of knowing what to measure in your plugin using OpenTelemetry metrics. This might sound straightforward, but trust me, even we've had to revise our metrics 4 or 5 times to get them right. It's surprisingly tricky to measure things that actually impact user experience without being too broad to be useful. While I absolutely love talking about performance, it's my favorite topic, we will save the deep dive for another day. Let's return to our test and look at what makes it tick behind the scenes. We are using the driver extension, which combines two key technologies: JMX, Java Management Extension, and a library for navigating through AVT trees. Now you might wonder why we need a special protocol for this test. Here, what is interesting: when you run a test, you actually have two separate Java virtual machines. running at the same time, one for your test and another for the IDE itself. They need to talk to each other, and that's where JMX comes in. We choose JMX for a few good reasons. It is a standard in the Java world. It doesn't require us to modify any classes. It works right out of the box without extra libraries. What JMX does is pretty powerful. It lets us access any class, calls its methods, and get results back. There is one small catch. You need to create interfaces for classes that pass between the two JVMs. But we won't get too technical about that today. In our test code, we are using these JMX calls to navigate through the avatar component tree, find the UI elements we need, and interact with them using Java's avatar robot. Think of it as a way to programmatically click buttons and interact with the IDE. Let's talk about running this test both on your machine and on CI. There is something important you need to know. Since we are using Java Avatar Robot for UI interactions, it actually performs real mouse clicks and real keyboard presses, and this leads to some interesting challenges on different operating systems. On macOS, you need to handle accessibility permissions. Here's the tricky part: if you don't have this permission set up, your clicks and keystrokes simply vanish into thin air. The worst part, the test won't even tell you something is wrong because the OS silently ignores these actions. Windows has its own quirks. You will need two things: run tests from the command line, not as a Windows service. Make sure you're logged in properly, and if you miss either of these steps, Windows thinks you're in a headless mode and the IDE won't start at all. So yeah, let's see how it works. You can see here how the test starts, navigates through IDE interfaces, just like a real user would do. So yeah, here we started IDE, navigating, checking, and yeah, have a green check. Let me show how flexible these tests are by writing another one together. We will keep most of the test structure the same, but let's make two changes. We will switch to testing in WebStorm instead of IntelliJ IDEA, and we will use a specific version, the release version of 2024.2. The best part making these changes is surprisingly simple. We just need to tweak two things in our test case object: change the product provider to specify WebStorm, and add with version call to target the exact version we want. Let me show you another useful feature. Instead of starting from the welcome screen, we can begin our test with a pre-configured project. In this example, we will pull the latest version from the master branch from GitHub repository, but that's just one option. You can set up your project in any way that makes sense for your testing needs. The rest of our configuration stays the same. We still need to install our demo plugin into the IDE. Let's look at the actual IDE startup part of our test. We use two important methods here: run IDE with driver to launch the IDE itself, use driver and close IDE, which takes a block of code that we want to execute. In this example, we are keeping it super simple. Our code block is empty, so the IDE will just start and shut down right away. Of course, this isn't very useful by itself, but it shows us the basic structure we need. In our next steps, we will add the actual test actions inside this block. When we run this test, we will hit a small bump. An activation dialogs pop up asking for a license. But don't worry, there is an easy fix for this. We can handle it by storing our license key securely as a base 64 encoded secret in GitHub, and then use the set license method to provide it to the IDE. Think of it as giving the IDE its credentials before we start testing. This way, we won't get interrupted by any activation prompts during our test run. Let's start writing our actual test logic. One of the most common things we want to test is opening a file. Seems simple enough, right? We can use the open file method and just pass it to the file path. But here's the crucial tip I've learned the hard way. If we just try to open the file immediately, our test might be flaky. Sometimes working, sometimes failing. Why? Because the IDE needs a moment to get fully ready. All those background processes and indexing need to be completed first. That's where wait for indicators comes in. It makes sure everything is fully loaded and ready before we try to open our file. This simple addition makes our test much more reliable. Now let's test something more specific to our plugin, its own actions. We can do this using the invoke action method, passing in our actions ID. In my demo plugin, I'm calling the show dialog action. Here's something interesting about how this works. You might notice the now parameter is set to false. This parameter controls whether the test waits for the action to complete, but there is a tricky part about modality that is quite important to understand. When we start, we are in the default modality state. Think of it as our base level. When a dialog opens, it creates a new modality level. If we tell our test to wait for completion at the default level, it will keep waiting forever because it can't see what is happening in the dialog's modality level. Let's work with our dialog step by step. We need to first find the dialog using its title, test dialog, then locate the OK button inside it, and finally click that button. There is something clever about how this works. Notice the nesting pattern. IDE frame, then dialog, then button. This isn't just for organization, it actually helps us find components more precisely. When we look for the OK button, we are only searching inside our specific dialog, not everywhere in the IDE. This makes our test both more reliable and faster, since we are looking in exactly the right place. Let me show you a really useful debugging tool that helps you write UI tests more easily. Remember when I mentioned the drivers creates an avatar tree? Here's the cool part. It converts all UI components and their properties into HTML div elements. This means you can use standard XPath to find exactly what you need in the interface. Now, I know XPath can be a bit tricky to write, which is why we provide XQuery Builder to make your life easier. But here is an even better tool. While your test is running, we automatically start a small web server in the IDE. Just look for API remote in your build log to find the port number, open it in your browser, and voila, you'll see a live view of your UI tree. Looking at the screenshot, you can see exactly how our test dialog is represented. There is a dialog with its title and the OK button where we are working with. This makes it much easier to figure out how to reference UI elements in your test. Here's the really practical tip for writing your test. Since we generate standard HTML, you can use any browser developer tool to test your XPath queries right there. Just open Chrome or any other browser you prefer, paste your XPath into the search box, and instantly see if it finds the right elements or not. And there is more. While we keep the web view clean and readable by default, you can find additional attributes that might be useful for your tests. For instance, if you need to find a component by its Java class name, which is pretty common, you can see that information right here in the HTML. This makes it much easier to figure out exactly how to identify your UI elements. Let me show you our test in action. As you can see, everything happens just as we wrote it. Our test opens the project, patiently waits about 10 seconds to make sure all background processes are truly finished, And yes, those indicators sometimes pop up when you least expect them. So it's better to be safe than sorry. Then it goes through our test steps, opening the file, triggering our custom action, and clicking that OK button. I hope this demo helps you visualize how a UI integration tests come together from the code we wrote to what actually happens in the IDE. It might seem like a lot of steps, but once you understand the pattern, it becomes quite straightforward. Let me address what some of you might be wondering about. What is happening with the previous UI testing framework, which was called Remote Robot? Let me give you the full picture. The good news is that Remote Robot isn't going away. If you are using it, it will continue to work, but here's the thing. It's now in maintenance mode. We've actually moved almost all our own integration tests to the new starter and driver approach, which means all new features and improvements will be focused there. Now, if you are currently using the remote robot, don't feel pressured to change everything at once. You can keep your existing tests and gradually migrate them when you have time. From our experience, the migration is pretty straightforward and quick, and there are some nice benefits to switching. You can run tests in IDE split mode. The driver component comes built into all IDEs, so no extra plugins needed. Starter Framework gives you more configuration options, which means you can probably handle test scenarios that were not possible before. And let me share some exciting plans we have for plugin testing. First, we are constantly expanding our UI test coverage, which means you will get access to more UI fixtures to use in your own tests. And remember that integration between Starter and the IntelliJ Gradle plugin that we saw, we are working on making it much simpler. No more manual library list and pass configurations. We also want to make our test results more valuable for you. Soon you will be able to see test results right in the marketplace, similar to how Plugin Verifier works now. Plus, we are developing a new test that will automatically check all compatible plugins whenever we are preparing to release a new IDEA version. Now, we know documentation is never really finished, especially for sophisticated frameworks like Starter and Driver, and we are committed to improving our docs and examples to make everything clear and more helpful. And finally, we really want to hear from you. As you start using this new testing approach, please share your experience. Any issues you run into or features you find missing. Your feedback will help shape these tools to better serve your needs. Thank you all for staying with me today. If you have any question about plugin testing, feel free to reach out. You can email me or find me in the JetBrains platform Slack. I'm happy to help you get started with these new tools or discuss any specific testing scenarios you have in mind. Now let's open up for questions.
Thank you very much, Maxim. That was a great introduction to the work that your team has been doing in the recent time. Maybe one curious question from me up front. How many such tests do we have now for ourselves? I mean, inside JetBrain, can you share like a rough number?
Based on the starter framework, we have, I believe, thousands of them really. And using the driver extension, we have about, I believe, about 200 of UI tests.
Okay, that's quite a lot already. Yeah. So, a number of questions came up during your talk. Maybe we will start with the non-technical one first. I think you covered this a bit, but maybe you could reiterate how does it compare to the existing UI remote robot library that we advised for UI testing until now.
Yeah, so the new one is based on the previous remote robot library, but it was rewritten almost completely. So there is no like JS execution like it was before. Now we've moved completely to JMX. There is a full integration with the starter framework, which was missing. It was really a really long method with a lot of parameters before. Now you can configure everything in details. And yeah, but the concept of UI is very similar. So the same tree, same traversal of the tree, and so on. Just the mechanics and the execution part was changed, and it was mostly needed for support for the split mode, but also to cover some other scenarios.
Okay, so if a plugin already has UI tests, it should be pretty straightforward for them to migrate to this new framework, right?
Yes.
Okay. Yeah. Next one, how do you apply code coverage when running the IDE from the starter? And how do you set up the various outputs of the coverage results? Is that even possible?
Yeah, it's interesting question. We don't measure any coverage in our integration tests, and so yeah, probably there is some tricky way using some coverage agent or something like that, but yeah, we haven't looked into this.
Yeah, right. You would need to invoke the test using this Java agent and then somehow magically bring over the results to the development IDE instance, right? Okay.
Yeah.
Sounds a bit tricky. Is it possible to use this framework with CLine and Rider? I think the answer is yes, right?
Yeah, we support every IntelliJ based IDE right now.
That's great, yeah. And with the starter framework, it's actually just a one-line change to just target a different IDE or different version maybe of the IDE. Yeah. How will you get rid of bugs of unmaintainable asset J for Swing here? I think this is a question for the UI testing features.
Yeah, usually we write our own features to cover, for example, buttons or some sticky trees or maybe some tables. So yeah, and so far there were like no real issues that like prevented, for example, some scenario from executing. So everything can be fixed using the custom fixtures, and we do this.
Okay, so basically the testing DSL shields away all this magic for you, right?
Yeah.
Yeah. That is a simple yes/no question.
Yes, it is open source, and there are links at the end of the presentation, and yeah, we will
Okay.
share it.
Yeah, we'll try to figure out the link and post it in the chat. Yeah, Ivan.
I've already done that. It's already posted to the chat.
Oh, yeah, right, great.
Thank you.
Yep. We covered this and that. Yeah, so this question is pretty obvious. I think we don't really have documentation, at least not in the IntelliJ Platform SDK docs, that I know for sure. I think you have some kind of demonstration project or something where people can look for a reference, right?
Yeah, we have documentation inside the repository for the starter itself, for the drivers there, also some docs, and yeah, there is a demo project, but that's true, we need to integrate to the common docs.
Yeah. And I think that is somewhat related to the tighter integration to the IntelliJ Platform Gradle plugin that you mentioned in your talk, right? So
Yeah.
we try to deliver the out-of-the-box experience very soon, I
It's
guess.
done already.
Yes, but yeah, we will see how to document it.
Yeah, that's true.
Thank you. Sometimes in UI tests, you need to close and reopen the IDE to see if the expected persistence field is safe. So this is probably about testing settings UI and similar functionality. Can you do this in the new testing framework?
Yeah, it's possible. So, for example, when you invoke close, start IDE, close and use driver, it will be closed, but you can run it again, and every like config system folders and so on, they will be persistent. So they are like simple single folders for the single context. So yeah, you can reuse them and reopen the without issues. Yeah.
Great. So since the documentation technically is not really there yet, what is the best way for developers to stay up to date on all the testing framework stuff that your team is building? I would guess looking at the sources mostly.
Yeah, we're trying to provide changelog between different versions because sometimes you will need to migrate some methods, and we provide those paths of migrations. So yeah, this is another way to stay up to date.
One more feature question. Do you plan on adding a recording tool in the testing library? I suppose something like automatically taking a screen capture, basically, or maybe even like a screencast.
Yeah, it's actually already possible. So we capture screenshots every minute to preserve what is going on. We also save screenshot on exit, and if some error appeared, and there is the possibility to enable screen recording for the particular IDE run, and it will be like FFmpeg on Linux and some Java library on Windows and Mac. So yeah, you can see recordings at the end as well.
Yeah, I think this might be very useful also to debug your UI tests specifically, right? Because
yeah,
where we all know that UI is not UI on every target machine, and things can behave rather unexpectedly.
it's true.
Especially if you're just not aware of the differences because you always use the same machine for development. Or maybe you're just unlucky and most of your users only use Windows, for example, and then suddenly some poor Linux user is stuck with your plugin for some reason. Does Aqua help writing UI IDE tests? So Aqua is actually another IDE from JetBrains, maybe not so well known, which is targeted at writing and maintaining tests. My guess would be it's probably not really the right tool here.
Yeah, probably it can help with writing some selectors with those XPaths, but yeah, actually I haven't tested it, and Chrome usually is enough and always ready. So, yeah.
I mean, given that plugin developers always use IntelliJ IDEA in some version, I think, I mean, XPath plugin is available for IntelliJ. I'm not quite sure if it's also bundled in the community or not.
Yeah, there are automatic injections, but you need sometimes to match the tree with the XPath, and yeah, it's
okay, so it's a bit tricky then.
Yeah.
Okay. Yeah, so Jakub, do you have any questions or?
I'm good.
Okay.
Well, I'm good.
Then it looks like we covered all the questions from the chat. Maxim, thanks a lot for sharing these great news, and thanks to you and your team. I hope that we will have only perfectly tested plugins in the future, right? Yeah, it will help
very much
to raise the quality. Yeah. So thanks a lot for having this talk with us today. Bye bye.
Thank you. Ciao.